So, you got all my multiple emails. I promise you I'm not going to be like emailing you 30 times a day. Just started the semester, we've got a lot going on. So, but I did realize that like we covered everything that I planned to cover today so that we can move ahead, which is great. Always good to be ahead of the ball. That means maybe we can have a flex day somewhere in there. We can do that. Carswell.
That's it.
Yes, all right.
So I'm glad I couldn't find it.
You couldn't find it. No, it's the same place we were Wednesday. All right, so we got McKay, Carswell, Susan, Cooper, Ashley, Skylar, Wilson, Ethan, Cole, Danny, Mason, Caroline, Abby, Hugh, Hannah, Barrett, Joseph, Owen, Dennis, Charles, TJ, Karen. Good. All right. Okay. So, that's fine. Y'all are being really nice for sitting in the same seats. Now, if I see you outside this class, I don't remember your name. That would be impressive. Okay. All right. So, today we're going to get going. Turn off my nice intro music. And we are going to talk about research methods. It's so exciting. Like, between now and next Friday, it's like the most boring topics I think in here. I'm sorry. But we got to talk about this because we got to learn a little bit about how we do psychology before we start jumping into topics of psychology. All right? So bear with me because this is kind of foundational stuff. Right? We're going to talk about independent variables and dependent variables throughout this entire class. Right? So we got to learn a little bit about that. First, just to sort of go over schedule, right? This is what we're covering out of chapter 2, and this is sort of how we're breaking it down. Today and next Wednesday in class, we're going to talk about this stuff. Right? We're going to talk about experimental design, correlational design, and descriptive design. Today, we're going to focus exclusively on experimental design. Next Wednesday, we'll talk about correlation and description. Tuesday in lab, Tuesday at 2 o'clock is the next time that I'm going to see you guys, right, after today. Because we don't have a class Monday, it's later, right? That's Caroline.
Do we have lab at 2:30 on Tuesday?
2:30, yes,
Okay.
2:30, sorry. 2:30, because this is a Tuesday. It's 2:30, not Tuesday. So, 2:30 on Tuesday, in here. Yes, miss?
Do we need to bring any materials for that?
Yes, like stuff to write on. Yep, yep. If you have a beach ball you want to bring it, in lab, we're going to talk about the scientific method and research ethics. So that's what lab's going to be about. So we're going to have sort of a discussion lab. It's not going to be a data collection lab next week. Okay. So the next one I'll see after today, 2:30 Tuesday. Okay. By 2:30 on Tuesday, your first failure thought paper is due. So I just wanted to pull that up and show you on the Moodle page, right here. If you didn't, if you haven't purchased the book, you just click that link, right? So I just click this link. It's going to open up the library page. Any of these will get you to the book. Click on that. You can download the book for up to 21 days. You have to re-download it after that. You can read it online, right? And just a little bit about this. Everybody had this sheet in front of you, right? And this is also posted to the Moodle page as well. But these are the instructions for the failure book. So Failure is the second book written by actually a colleague of mine, Stuart Feinstein. So I do research in taste. He does research in smell and olfaction. And together, taste and olfaction are grouped together as the chemical senses. And so our National Research Society is called the Association for Chemoreception Sciences, ACHEMS, and we go to the same conference. We've been going to the same conference for almost 30 years now, so he's a friend of mine. He's a professor at Columbia University, in New York and has written 2 books. The first one, called Ignorance, we're going to see a TED Talk by him on Tuesday when we come in to talk about the scientific method, is about why ignorance is really important in science. And his second book, Failure, is why failure is very important. It's why science is successful, is failure. Most of the time, we fail as scientists. Every once in a while, we have a success, but failure is the key to getting to that success, right? And so I think, hopefully you'll enjoy reading this book. It's a fairly easy read. So for each chapter that we're going to sign, and we're not going to read all the chapters, and we're going to read them out of order, okay? Because we're going to read them in the order that they best fit with what we're talking about in this class. But we have 2 chapters. Usually we'll just have 1, but we're going to just start off with a bang because you guys are hitting the ground running. And we're going to do 2 chapters, chapter 8 and chapter 5, and each of them has a prompt, okay? And you can see here that the thought paper should have 2 parts. So you're going to have basically 2 thought papers in this first one, right? So you're going to have a chapter 8 where you're going to have a summary, a short summary of your take on what he's talking about in that chapter. No quotes, no anything like that. This is your words, your description of what's going on in that chapter, okay? And then below that brief summary of what you think the chapter's about, you're going to answer these prompts for chapter 8. What does Feinstein suggest is missing from the descriptions of the scientific method? What are some words that should be used to explain how science is actually done, okay? Wrap that up. Chapter 5, summary, and then the prompt for chapter 5 is what does Feinstein mean when he says failure demands of the scientist a level of integrity and personal responsibility. Yes,
Do we print this out, or do we turn
this
it
is a turn in on Moodle, okay? So you're going to type this out in a Word document, you're going to save it, you're going to submit it as a document to Moodle, okay? Using the link on Moodle. No later than when we start class on Tuesday. Danny and then Carson.
I'm just sorry, is it just what we interpret the chapter as,
Mhm.
or is it what he's like somewhat saying, and then our little spin?
I mean, I think both of those things can be the same. Like, you're telling me what you think he's saying in this chapter. Like, this chapter is about Feinstein believes this, or whatever, right? Something like that. Carson.
How do you like submit stuff via Moodle? Like I went on there and I clicked on like the files to go and see the assignments, but like I never saw a place to like actually write. So sure to do that. Okay.
All right, so as a student, this is what you see, right? You're going to come here and click on that link, right? And you're going to do add submission. You're going to drop your file right in there, and you're going to say, that was submitted to me. No problem. All right. Hopefully, everybody is getting their Wheaton textbooks in the mail and from the bookstore and wherever. I did post some PDFs, but I'm not going to continue doing that because, 1, it's a copyright thing, and 2, it's a time thing. So there is a copy of Wheaton on reserve in the library that I mentioned in my email. You just go to the front desk and say you'd like to check it out. You can read it in the library and then return it to the desk. Okay. If you want to do that. Any other basic questions, things, issues with Google? Good. All right. Okay. So we can get going here. Research is really important in psychology because if you remember last time, I showed you how psychology is sort of at the intersection of the natural sciences, the social sciences, and the humanities. And even though things like the humanities are important, we are scientifically based, right, as a field. Right? And so research, empirical research, is sort of the key to everything that we know in psychology, right? And everything we want to learn about human behavior and why people act the way they do. Right? And so our goal overall, remember, is to understand how our biology, our brain, is controlling our behavior, and what are the influences on that. How do we find answers? How do we find answers to these questions? What is all the knowledge base, everything that's in that textbook, has come from researchers doing experiments in order to understand and identify information. And that information has to be verified by other scientists. And so everything that we know, right, is based on empirical methods. What does that mean? What does empirical methods mean? Does anyone know what that word empirical means?
The knowledge that should be acquired through observation.
Yes. Knowledge is acquired through observation. And in particular, we have systematic observation as our evidence. And there's sort of two ways we can get that observation. It can be quantitative, meaning we can somehow measure that behavior with some variable, right? With some thing that we're detecting. Right? It can be qualitative. What's qualitative? What's the difference between quantitative and qualitative? Anyone know?
Qualitative.
Sorry, go ahead, Scott.
Qualitative has to do with the senses, like touch, taste, smell, see.
Yes, it's more subjective, right? And so this is someone's report of something, right? I'm going to ask you a question, and you're going to tell me how you feel about that, or you're going to tell me what you perceive about that, as opposed to me observing your behavior and measuring something. That's quantitative. That's the difference between quantitative and qualitative. Now, we also have non-empirical methods. These are things that are not observable behaviors. Right? It doesn't necessarily make them any less important or critical. They're just different. Right? So, and there are some empirical methods that are flawed, right? That are not great, and we're going to look at some experiments that were maybe poorly designed or have some flaws in them, and try and identify what that is, right? And there can be non-empirical methods that can be flawed as well. But good non-empirical methods are things like meta-analysis. So a meta-analysis is where you take other people's empirical studies and mush them all together and try to make sense of everything. So say we have 50 studies that have all been done on working memory, on what our capacity for working memory, how much information can we hold in working memory. 50 researchers have published papers on this topic. I'm going to take the results from all 50 of those studies, combine them and analyze them together to say, overall, out of all these 50 studies, this is what the common thing is. That's a meta-analysis. It's like an analysis of other empirical research. You can also have things like critical studies where you are critiquing other people's research. Again, though, this one is a little bit more, tends to lean more over here on empirical because I'm using empirical data. These two, where you have people's opinions on research and people's criticisms of research, is really based on that person's bias, right? That person's ideas, right? And so that's sort of the difference between non-empirical and empirical. Empirical is more non-biased because we are trying to, we have more controls in place. Yes. All right, are we good on empirical versus non-empirical? Okay. All right. So these three different major research designs that I talked about, experimental, correlational, descriptive, each of those is trying to get at a different way of knowing, a different type of question. So if we want to describe something, we might use an observational design. If we are trying to predict something, then we might use a correlational design. Correlational design is saying, what is the relationship? Does this thing relate in some way to this thing? Can it predict something? And then if we want to try and explain something, then we might use an experimental design. The observational design, I was using the word descriptive design, that's sort of the same thing. Those are kind of interchangeable. So observational and descriptive as we're describing, right? And so today we're going to focus primarily on the experimental design. Like I said, we're going to focus on that today. All right, so we're going to see what you know here. I'll show you a study. This is a study by Pennebaker and Francis. Their research question was, if students write about adjusting to college, does it improve their well-being? Right? So what would we call this in scientific terms? A hypothesis, right? So a hypothesis is the question, the research question that's trying to be asked. Okay? And so that's research question. Now here's how they're going to ask that question. Okay? They have 36 first-year students in one group. They're asked to write about emotional events. They're asked to write for 3 days, about 20 minutes each day. They have 36 students in another group that's asked to write about superficial topics, not about emotional events in their life, right? They're asked to write about, what did you hear about in the news today, or something like that, okay? Then, they went and looked at these students' number of visits to the Wellness Center and their first semester GPA. All right? So here's where we get to see what you know. Does everybody understand the experiment? All right. So what is the N? What does that mean? Danny? Good guess, but no. Yes, there. The sample size, right? So in psychology, we like to use a whole bunch of abbreviations. I don't know why I didn't invent it. I just got stuck with it. So sample size is N, the letter N, particularly big N, represents sample size. All right? So what is our sample size for this study? Yeah, 72, right? Now, what if I asked, what is small n? So big N equals 72. What about small n? What if it's not a capital N? Does anyone know what that means? Yes, that is a subset of the big N, right? So the little n would be 36 because there were 36 in each group, right? Does it matter if there's 36 in each group? What if there were 6 in this group? That'd be okay? If we had 36 in this group and 6 in this group? I see some people shaking their heads. Why?
Like the answers would be skewed.
They'd be skewed? Okay. Why would that happen? You have more data for one side than the other, right? So there's going to be variability, right? So I've done research with colleagues in chemistry and colleagues in physics. And in chemistry and physics, when you do an experiment, when you do a chemical reaction and you put chemical X and chemical Y together, they always do the same thing. If you use the same concentration of each one and put them together 100 times you get the same thing, right? If I'm measuring gravity and I'm dropping weights from a certain height and measuring how long it takes to fall, it will be the exact same time every single time. There is zero variability in most chemistry and physics. I'm making it overstate because there are some variables. But in general, right? In psychology, we hardly ever get zero variability. We have huge variability because we're dealing with people, and people are complex, and everybody doesn't respond the same way, right? And so sample size in something like chemistry and physics doesn't matter as much to them. When I've done experiments, I'm like, we gotta recruit 36 subjects for this term. Why can't we do it with 4? Because, I mean, I know in chemistry you do it 4 times, you get the same answer 4 times, you're good to go. We won't get the same answer 4 times in a row, right? And so that's a big difference in the type of science that we do in psychology versus in some other science, physical sciences, right? Same thing in biology, right? When we're dealing with organisms, right? When we're dealing with nature, there's a lot of variability. Okay, so it's important that we have good sample sizes. Statistically, it helps if you have the same sample size. I mean, we could have 30 and 36. That really wouldn't be much of a problem. But statistically, if you have the similar numbers, it helps there as well. All right. Okay. What is the independent variable? Now we're really seeing what you know. We could start with what is an independent variable, but do you know, Danny?
Independent variable is
It's independent, doesn't rely on anything else, right? Did you want to say something, Carson?
Doesn't it not change?
Right, it's something that's not going to change.
It's like what we're putting into the experiment. It's like what we're doing.
It's what we're doing, what we're inputting in. It's the question we're asking, right? It's what the scientist is asking, right? So in this case, what would be the independent variable? The writing, right? So one group is writing one way, the other group is writing another way, right? That's the question we're asking. That's the independent variable. Independent variable is what type of writing they're doing. Very good. You guys do know. Somebody read the check. All right. What is the dependent variable? What's the dependent variable? The outcome based on the independent variable. It is what we are measuring. So somebody tell me, McKay, what are we measuring in this experiment? Or you got a question?
No, I was just going to say, is the number of visits to the health center?
It is. And
GPA.
and GPA. So we have 2 dependent variables. Often we'll have multiple dependent variables. Sometimes we'll have multiple independent variables. That starts to get complex because then you're like, well, which independent variable caused the change in the dependent variable? But sometimes experiments are complex. Sometimes we can't isolate it down to one thing. We want, often in an experiment, we talk about controls, we want everything else to be as similar as possible. Do we want first-year students in this group and seniors in this group? Because that introduces in another variable, right? So we want all the other variables to be as constant as possible. Do we want to try and get equal amounts of male and female students in here? Maybe if we think that gender might have an effect on this, right? Maybe if we're interested in gender as an independent variable, maybe we want a male group and a female group. That becomes a new independent variable. 2 males and females with writing have different outcomes, right? That would be an example of having 2 independent variables in that experiment. You guys are doing good, doing good. All right, so just so you know, the students that wrote about emotional events in their life had fewer visits to the Wellness Center and higher GPAs. Right? You can Google this and read that study. It's out there on the interweb out there, right? So, I don't know, maybe you guys want to journal a little bit. Like if it reduces your chances of going to the Wellness Center and increases your GPA, let's take a couple of minutes in the next couple of weeks and write down the emotional events that are happening. It actually helps to express that stuff. Think about it. Okay. All right, so As I mentioned, in the experiment, we want to try and control the variables that we're not interested in. And it's not that we're not interested in them, it's just not a question that we're asking right then and there. So we might be interested in gender in that study, but for that study, we want to eliminate that as a possible variable and control for that. So we want to try and control as much as possible in the study, except for the things that we're interested in. The independent variable is manipulated by the researcher, and it can have different levels. How many levels of the independent, if the independent variable was types of writing, how many levels did we have in that last study? 2. Could we have had more? Could we have had a group that did no writing? That would have been 3 levels, right? Okay. So, and in general, we're going to try and have a comparison between an experimental group and a control group. We can have 2 basic types of design. We can have what we call a between design and a within design. All right. What's the difference between a between design and a within design? It's sort of in the name. What type of study do you think that last one was that we talked about? Between. Why is it between? Because we had 2 groups. We had an experimental group, we had a control group. We're looking between 2 groups, right? What do you think? How could we redesign that study and it's a within study? Could we? What does within mean?
Would it be within the group of 36?
It would have to be within the group of 36. So students come in and don't do any writing, and you look at how many times they visit the wellness center and their GPA, and then the next semester you have them do this and look within the same group, and does writing then decrease, does it change the number of visits in the next semester? What would be the issue with doing that? Or is there an issue with doing that? Could we redesign that study and do it within in one semester or the next semester?
We already have a semester of college now.
Yeah. Do you think your first semester of college is probably fundamentally different than your second semester in college? Yeah. I mean, hopefully you learned something in the first semester and you're doing something different in the second semester. So that becomes what we call a confound, right? A variable we can't control. Write that down, confound. A variable we can't control. Or a variable that was not controlled. Something that can muck up our research. That's the informal definition. All right. The dependent variable is what we're measuring. What we're measuring by the research. And we want, ideally, we want that to be quantitative. What does that mean? Numbers. So in that previous one, was it quantitative or qualitative? Quantitative, why? What did we measure? Number of visits. You had 0 or 100. Hopefully not 100 visits. But it's some number, right? Your GPA, that is a number. That is quantitative. If we wanted to add a qualitative dependent measure, what could we do? What is qualitative? Yes.
Like just mentioned, but maybe instead of just measuring like if they improved their GPA, like how much certain people improved.
That would still be quantitative. A good try.
You could ask them about their like emotional well-being, maybe.
Yeah.
Subjective view of how they feel.
Exactly. That would be a qualitative approach. At the end of the semester, how do you feel this semester went? Rate your emotional well-being on a scale from 0 to 10. That's qualitative. And it's more subjective. It's subject to things like bias that we'll talk about, right? Is it important? could be, right? I mean, what if you had the group that wrote about their experiences had less visits to the wellness center and a higher GPA, but they overall felt worse than the other group, right? Then maybe you change your outcome to say, hey, maybe making students think about negative things, write about negative things that happen, isn't a positive thing for them to do, even though it improves their GPA. I'm just thinking that out. I mean, that was the part of it. But what I'm saying is that sometimes people think of qualitative as weaker, right, or less scientific than quantitative, but it has a place, right? It has a place, and it isn't always necessarily that way. And some things you have to ask people. You can't quantitate. All right. So we're talking about another effect. Anyone ever heard of the Mozart effect? Ever heard of the Mozart effect or seen baby Einstein, maybe Mozart things, right? So the research question was, does listening to classical music influence development? We're going to talk about development in several weeks. It's our pillar 3, right? And so the hypothesis is that listening to classical music will increase babies' IQ scores, right? And the theory behind that, often a good hypothesis has some basis. Researchers aren't just sitting down going, I wonder if people eat 10 eggs a day if that'll make them smarter. Like, why would you think, like, sure, that's a hypothesis. What's it based on? Like, why would you think that would cause that, right? So the idea is that this helps somehow change the way the brain develops. It helps stimulate the creative right side of the brain, which is not true. We'll learn about that as well, right? It's a myth, right? And so different ways that you could design this experiment. Right? If this is your hypothesis, you could do a descriptive or an observational design, a correlative design, or an experimental design for this. Right? And I mean, this is a real thing. Like, people are buying this stuff, right? I mean, this is a real website. Right? And it's not just for that. They got all sorts of healing sounds, right? We have all sorts of YouTube is full of videos like this, right? Okay. All right. So, in-class assignment. Get out a piece of paper. You're going to turn this in. It's a separate piece of paper from where you're taking notes. We got something to write on. We're going to take about 5 minutes. If you were to design Saxon salad. So go ahead and if you were going to give you some classical music to stimulate your brain, go ahead and answer. We're going to have 9 questions by the time we're done. This is part 1. There are going to be 3 parts to this. So go ahead and write 1, 2, 3, 4, and write down what would be the independent variable, dependent variable, hypothesis, and what other variables. This is for a grade, right? The thought paper on tattoos was just a starter. You were graded on that. This is going to be for in-class grades. Go ahead and answer those 4 things. I'll quit talking.
Can we use our lips? Can we use our lips?
Yeah. So,
You're bringing music.
okay. So, the original Mozart effect article research that was done was back in 1993. And the design was they played a type of sound prior to the test. It was what you just listened to. That music that was just playing was Mozart's sonata for two pianos in D major. There was 3 other groups. So what type of study was this? Between, with 3 groups, right? They had a listen to classical music group. They had a group that got relaxation instructions. So they listened to a tape of someone giving them instructions on how to relax. And then a group that got 10 minutes of silence, right? They're dependent variable. They showed them this piece of paper getting folded in half, that piece of paper getting folded in half this way, then getting folded in half this way, and then if we cut off that corner and unfolded it, what design would it produce? Right. And this is what they found. Right. The ones that listened to music, right, had a higher score, 119 over here. So this test is a spatial reasoning test from the Stanford-Binet IQ test. So the Stanford-Binet IQ test tests 5 different domains of your intelligence. One of them is spatial reasoning. This is one of the tests for that. So from that, they can then deduct these scores. And so in the relaxation and science, this is what they found. Relaxation and science categories, they found basically similar scores. Here, they found a higher score. And this was their conclusion. Right? After listening to Mozart, subjects did better on this spatial reasoning and test than if they hadn't listened to Mozart. Right? Some of the things that they talked about, other variables that they controlled for, but they thought might be interesting to look at in the future, included, does the amount of time matter? They held it at 10 minutes, right? Does it affect other types of general intelligence besides this spatial reasoning they focused on? Does the type of music, classical versus non-classical versus different types of classical, piano, different instruments, does that matter? So all these different questions you can think about, future directions with this. All right. So, second part, and again, we've got to get through this today. So, I'm going to give you about 3 minutes to answer these 3 questions, 1 minute each question. What conclusion? What do you think could cause this? What are possible confounds? I'm not giving you a lot of time, but let's try and wrap this up so we can get to the last 5 minutes. One more minute. All right, 30 more seconds, wrap it up. Okay, switch back to your notes that you're taking in class, from your assignment page back to your notes page, right? And I want you to write down slide 12. Dr. Pittman is skipping it. We're going to cover it next time. We'll come back to this. So in your notes, you don't get confused. I have no notes for slide 12. We skipped it. We're going to come back to this because I want to finish talking about the Mozart effect. 1999, fast forward 6 years later. Experimenters say, I'm not so sure about that. An important part of science is replication, right? If it's a true thing, we should be able to do this multiple times and get similar, maybe not identical, but similar results each time, right? So these researchers use the same 10 minutes, the same sonata. They added, however, a second music category. Which was this, right? People described it as kind of obnoxious, a little grating, not really pleasant. How would you describe the Mozart? Better or worse than this?
Better.
Better? I didn't play that one. All right. And silence. And then they did the same paper folding. Now, they did something different. They added a within subject component where they did a pre-test. They had subjects come in and do an example of this, a different one, on one day, and then come back the next day and listen to the music and do it again. So they got some practice with the test. They got a baseline measurement. So while they had a between, they also had a within. Sometimes you can have both, and we call that a mixed design, because we're mixing within and between together. And this is what they found, right? So they found no difference in the pretest, which you would expect. We just have 3 random groups of people. We hope that they all perform similarly. Their hypothesis would be that in the post-test, after listening to the music, there would be a difference between the groups. They found no difference between those groups. All right. What do you notice about the pre and the post-test? It went up. Why do you think it might go up? Because they practiced it once, right? They learned something from having done this. That's what we call a practice effect, right? All right. I'm going to skip that. We'll come back to that. But briefly, in the last minute before you leave class, what is your conclusion? Would you play Mozart classical music for your kids? And what do you think about the design of these studies, and why do you think it was different and not different? Tell you what, let's do this, because I know we're out of time and I know you all have classes to go to. We're gonna practice submitting something on Moodle. All right? So I'm gonna have you type out these answer to these 2 questions and submit it sometime this weekend, let's say by Sunday. I would do it now, as soon as possible, so you don't forget about it. But I will go right after class and put a link on Moodle. Just like I showed you for the failure paper, you're gonna make a document, submit it with the answer to these 2 questions. I'll post these 2 questions to Moodle. Let me have your other things right now, and we are good to go for the weekend. I will see you all Tuesday, 2:30 in this room.